Hello, am I audible?
यस सर सर रिकॉर्डिंग स्टार्ट कर जी ठीक
Are there participants? Hello, Prasanti. Hello, everyone. Am I audible? I am Mohammad Sajjad Athar and your instructor for the course on particle physics. And you had the complete lectures on particle physics, which is started with the general introduction to the particles. Why one should study particle physics? We had started from there. Then the classification of particles, and where we discuss about the fermions and bosons, and then what are the particles which fall in the category of fermions, and what are the particles which fall in the category of bosons. Then fermions were further classified into two groups, leptons and baryons. And leptons are those particles which do not participate in strong interaction. They are all elementary particles. They don't have any structure. And there are three families of leptons, which we call by the name generation 1, generation 2, and generation 3 leptons, where we have the electron family, muon family, and tauon family. In each family, we have two particles, electron and its electron type neutrino, then muon and its muon type neutrino, and tauon and its tauon type neutrino. Then there are antiparticles, For electron, the antiparticle is E plus, which we call by the name positron. For mu minus, the antiparticle is mu plus, and for tau minus, the antiparticle is tau plus. For electron type neutrino, the anti-type particle is electron type anti-neutrino, and similarly for others. And these particles are assigned individual lepton number for each family, for or what we call by the name for each generation. For the electron family, for the particles, we define electron lepton number to be +1, for antiparticles to be -1. For the muon family, we assign muon lepton number to be +1, and for muon anti family, muon lepton number to be -1, and similarly for the tauon family. Then we have baryons, and in the baryons there is only one quantum number that we call by the name baryon quantum number, and this is +1 for all the particles like proton, neutron, lambda, sigma, cascade, delta, etc. And then we have antiparticles like antiproton, antineutron, anti-sigma, anti-delta, etc., for which baryon number is -1. And then we have bosons. In bosons, we have two categories. One we call by the name mesons, and another by the name the mediating quanta or intermediate vector particles, which mediate the interaction. And in mesons, we have pions, we have kaons, eta meson, rho meson, etc. And for intermediate particles mediating quanta, we have gluon for the strong interaction, W and Z bosons for the weak interaction, and photon for the electromagnetic interaction. Then we also discussed about the conservation laws in the particle physics. There are 7 exact conservation laws and 7 approximate conservation laws. And the 7 exact conservation laws that we discussed in this class were energy conservation, linear momentum conservation, angular momentum conservation, charge conservation. These 4 conservation laws are given by nature. We cannot at all violate them. But there are 3 additional conservation laws which we know by the name lepton number conservation, baryon number conservation, and CPT conservation law. These 3 are the part of a standard model of particle physics today, which we believe in that theory. Therefore, we have 7 exact conservation laws and then 7 approximate conservation laws like isospin, third component of isospin, strangeness, charge conjugation, parity, time reversal, and CP. Now, it is not necessary for any interaction to obey all these 7 approximate conservation laws. If any interaction process obey all these 7 conservation laws, they fall into the category of strong interaction process. If all the laws are obeyed except for isotopic spin, then we categorize them into electromagnetic interaction process, and in weak interaction process all of them get violated. And this is the basis of the classification of electromagnetic interaction process, weak interaction process, and strong interaction process. Therefore, these are the different processes and the examples which we have discussed in this course. We have also discussed how to see that any process will get executed or not based on the lepton number conservation, baryon number conservation, energy conservation, charge conservation, etc., which fall in the category of exact conservation laws. Therefore, if we have been given any process and it is asked whether that is a possible process or not, that will be checked by looking at the exact conservation laws. But if a process is observed, then we have to see that whether that falls in the category of electromagnetic interaction, strong interaction, or weak interaction. Then we apply the approximate conservation laws, particularly isotopic spin and third component of isotopic spin, and both of them are violated in weak interaction. Isotopic spin is violated in electromagnetic interaction, and none of them gets violated in a strong interaction process. Then we discussed about uh, the properties of the particles. How do we understand them? We talked about uh, the hadrons, which are baryons and mesons. They together they constitute hadrons, and hadrons have got composite structure. They are not elementary particles. They are made up of either 3 quarks in the case of baryons and quark anti-quark pair in the case of mesons, and these hadrons also participate in a strong interaction process, while leptons do not participate in a strong interaction process. And it does not mean that hadrons do not take participation in electromagnetic interaction or weak interaction. They take participation in all the 3 processes that we talk about, with strong interaction, electromagnetic interaction, and weak interaction. And then when we talk about the quarks, what are the evidences which support that really hadrons are made up of quark anti-quark pair in the case of quark anti-quark pair, or the baryons are made up of 3 quarks. There are evidences in support of the quarks having as the building blocks inside the hadrons, and these quarks, they carry independently baryon number, they carry charge, they have also been assigned isotopic spin, and the third component of isotopic spin, to explain strange baryons, we assign a strange quark to have a strangest quantum number -1. Then using SU6 algebra, we try to get the flavor and spin wave functions for the baryons and mesons, and using those in terms of quarks, and using those flavor wave functions, we have obtained in this course the charge of the baryons and mesons, as well as the magnetic moment for the baryons and the mesons. We also looked at the decuplate structure of hadrons, the non-net structure of the mesons, and the octet structure for the baryons, etc. And based on this structure, Gell-Mann and Zweig independently coined the term quark and for the particles. And after that, we also discuss in this course about the neutrinos. As we know that neutrinos are the second abundant particle after the photons, and they are weakly interacting particle. But because of this interaction, which is of weak nature, it is very difficult to observe these particles directly, and therefore we have indirect evidences to say that we have observed neutrinos. We have discussed in this class how Rines and Covans were able to conclude that they have observed neutrinos at Savannah River reactor. Then muon tap neutrino and tauern tap neutrinos were discovered by another experimental collaborations. We talked about the solar neutrinos, solar neutrino puzzle, and how this solar neutrino puzzle, as well as when we discussed about the atmospheric neutrinos, we also talked about atmospheric neutrino anomaly. And then to understand or to solve these puzzles, we need neutrino oscillation phenomena, where neutrino flavor states and neutrino mass eigenstates are different. And when neutrinos, they propagate in space, they propagate in some linear combination of neutrino mass eigenstates, and we obtained the expression for the probability of oscillation for a flavor nu e to nu mu or nu e to nu tau, etc. We also discussed about the neutrino oscillation in matter and other topics. Then we also discussed about the Big Bang theory, how the different elements in the universe were formed. In fact, we started with hydrogen and helium, which were synthesized during Big Bang nucleosynthesis. Then the formation of mid-sized elements in the star's core during the nuclear fusion reaction, and finally the formation of heavy elements like uranium, thorium, plutonium, etc. in the during the death phase of stars, where we discussed about supernovae, supernova explosion, and other phenomena. Therefore, this course really gave us a flavor of the fundamental entity that people are looking for, what are the properties of these particles, what are the different efforts which have been made to understand these particles. And I am sure that you must have found this course to be useful. In fact, this is many questions are asked from these topics in NET, JEST, and other courses, where, for example, we have also discussed about the kinematics of the reaction, where we talked about the laboratory frame, we talked about the center of mass frame. I told you that sometimes laboratory experiments are preferred, sometimes the center of mass experiments are preferred, but the center of mass energy required for the uh, experiments at LHC, which is say 14 TeV for proton-proton collision. If we want to replicate such experiment in the laboratory, then we need an energy which is currently not possible in the laboratories. Therefore, somewhere to see exotic particles, new particles, to create a scenario which mimics the part of the Big Bang, we need center of mass experiment. But if we want to study a specific reaction, we need laboratory experiment. Then I also discuss about the accelerators, the linear accelerators, circular accelerators, etc., cyclotron, betatron. Then we also discuss about the particle detectors like bubble chamber, cloud chamber, Cherenkov detector, liquid scintillator detector, etc. And these detectors are being used to detect particles, and all the detectors are not of the same type, and it depends upon what type of detector you want to have a particular to detect a particular particle, and that is why worldwide lots of efforts are being made in the detector technology, in the development of detector technology, in the development of accelerator technology, and so on. And this is the experimental aspect, where we have discussed about the laboratory and center of mass experiments and accelerators and detectors. If you have any questions, you are free to ask.
देखिए नेट आया नहीं यार।
हेलो
Approve नहीं मैम की वजह से, पूछने की वजह से कर रही हूँ।
हेलो
जी सर।
मेरे ख्याल में कोई उधर से तो चेन्नई से कोई नहीं है ना पार्टिसिपेशन।
जी सर, आपको फिर बनाऊं होस्ट या नहीं अभी?
होस्ट तो आप बना चुकी थी मुझे।
नहीं नहीं, वो बीच में नेट का कुछ इशू हो गया था
हाँ
थोड़ा
हाँ,
सा।
बना दीजिए।
जी जी सर।
हेलो एम आई ऑडिबल?
यस सर।
हम दो के अलावा तो कोई नजर नहीं आ रहा इसमें।
नहीं सर, कोई नहीं है।
मेरे ख्याल में वो लोग भी नहीं है कोई। क्या करें, स्टॉप कर दें यहाँ पे
जी सर।
या 10 मिनट और रुक जाते हैं?
ठीक है सर, ठीक, ओके।
हाँ, इसको क्लोज कर दीजिए लाइव सेशन, है ना? हेलो
जी
हेलो,
जी सर।
इसको क्लोज कर दीजिए।
अच्छा सर, थैंक यू।